Thank you, Neo. Good afternoon, everyone. I'm going to talk a little bit now about something a little bit different than we've talked about previously. And this is using large language models to actually generate assessment questions. I'm going to talk specifically about clinical medicine, but this can be applicable elsewhere. So for those of you who attended our presentation yesterday, some of this may seem a little familiar, and it's because this is part of the same experiment/study that we did throughout the year. We know that large language models can generate natural sounding language text, and they're very good at that. And they can also very convincingly pass medical examinations. For example, a specialized large language model was given the United States medical licensing exam, and it achieved 87% as a result, one of the highest ranges of scores that they can get. These types of professional body exams that we eventually train our students to do, we talked about the types of assessments in the previous session, but they are still all multiple choice questions. They are still in the sit-down format. I'm not going to go into all of that, but these types of assessments benefit from firstly well-written and understandable multiple choice questions, and especially when these types of questions contain plausible clinical scenarios that the respondent can reason through. We know that these types of multiple questions are at least similar in their quality, if not superior, in terms of reliability and validity, and also testing higher order clinical thinking to, sorry, what I didn't include there, to written questions, if they are written well. We saw this graphic in Monday in Professor Pratchka's talk, and this was a indication of the progress that we had this year in large language models. At the top here, we see the response of large language models in what is called the Massive Multitask Language Understanding Test. And this is a test about a lot of different topics that is given to large language models to see if they can answer the questions actually. And we have old models here at the top. By old, I mean from last year. And we see from the green, we start seeing GPT-4s, the latest version of GPT, its score. And even in different languages, it achieved a lot. And with one of the rarest languages in the world, Telugu, it achieved a good score in this multiple, in this task. Now, I've tried to find, and I can't find any evidence of language models creating clinical questions. And we know that these types of questions are necessary in addition to other types of assessment for testing clinical reasoning or just reasoning in general from students. So we decided to test questions created by large language models against those created by content experts. Now, we decided that we were going to use, in the spirit of equity and accessibility, language models that are generally available to the public. So nothing paid, nothing difficult to use. So we decided on keeping with these three, GPT 3.5, which we can access through the ChatGPT platform, GPT-4, which we can freely access through Bing, and Palm, which is the language model that drives Bard or Google's AI. We did a little pre-trial just of creating 5 multiple choice questions from each model. And we gave this to our colleagues. Our colleagues all agreed that GPT-4 produced superior quality questions. There were a lot of problems with questions from the older models, and I think we can see that in the test scores for those models. They didn't achieve nearly as high a score as GPT-4 for various technical reasons. Another thing that pushed us towards GPT-4 was its ability to understand our prompts, especially complex prompts, which the other two models had much difficulty understanding or interpreting, rather. Now, this is an example of what we gave GPT-4 in order for it to create a question for us. So we said, I will give you some information about a medical topic. Please verify that the information is accurate and up to date by using reliable sources. And then we gave it some instructions for the language. For example, we said it should be in UK English, etc., and that it should confirm these instructions by telling us what it's going to do. And so it did. Now, at this point, I never believe what it says because a lot of the time it doesn't follow your instructions anyway. And I'll talk a little bit later about the battles we had. GPT-4, as I said, understood these prompts the best of all of these. And I gave it some information about a medical topic, in this case, a hormone. It said, yes, the information is correct. We can see here it searched recognized scientific sources for that information. And it then created a question, a multiple choice question based on the information. Now, this multiple choice question, it was quite basic. So what I did next was, everything is correct there. What I did next was I told it, using that same information, create an apply level question in the form of a patient scenario. And it created not a bad question. So it gave symptoms of a patient, habits of the patient, etc., and then asked from the information what is most likely to explain the patient's symptoms. So really not a bad question that it created there. It is hit or miss, but in this case, it was a hit. So we took the hit questions, and we also took some staff-created questions. And we put them in an assessment. Now, before the assessment, we evaluated all of the questions for clarity and precision of the question, of course, alignment with the course objectives. Part of the reason why we gave the language model the information instead of just asking it to write a question about a topic, because we couldn't be certain that it was going to give us a question that aligns exactly with our course objectives. And we also noted the need for major or minor editing of the question. So major editing was something like the structure of the entire question or more than one question option or answer option. And minor editing was things like language and one answer option. Then after we evaluated this we spread the questions out over 4 sit-down assessments in 71 respondents. After that, we pooled them all together and analyzed the results. So we looked at discrimination and difficulty of the questions and also what it took to get the questions in the assessment in the first place. Here are our results. So we calculated for the language model questions. We had 117 questions that came from language models. And from our staff, we had 154 questions. And I'll explain why there's such a difference between the number of questions. But for these, we calculated the difficulty index and the discrimination index. As you know, the difficulty index, as it comes closer to 1, the question becomes easier. So the language models questions were very slightly easier than questions from our staff, but not by much, and it wasn't significant. Also, the discrimination index, which says how many high-performing students had the question correct versus how many low-performing students had the question correct. This was also very slightly lower for the language models, but again, not by much. No significant difference there. Where the significant differences came in was in the amount of major edits required. For the language models, almost 40% of the questions that, and this is the questions that we didn't throw away, required major edits. So something about the sentence structure that didn't make sense, or a lot of the options didn't make sense. For the staff, it was less. It was a little bit much, in my opinion, but it was less. But compared to the total amount of questions, it was quite a bit less than that of the language model. The minor edits, here we have it switched around. So the language models, if there were minor edits required, it didn't come from the language models, it came from the staff. And the reason for that, I'll get to the rest of the points, but the high amount of minor editing in staff-graded questions were mostly due to language errors and grammar errors and formatting errors. So mostly language errors. Now, what we find here is that language models, and especially GPT-4, can generate high-quality multiple choice assessment questions and solutions. So you ask it to explain why the options are correct or incorrect, and it can explain that as well. And this is not part of this work, but I've also used it to give feedback on question choices, and it does that quite well. I must emphasize that it can generate high quality questions when used correctly. Now, what is correctly? We'll see that in one moment. We, however, encountered quite a lot of limitations and challenges while trying to use the language model in this way, including hallucinations. If you don't know what that is in a language model, it's when it just starts to make up information. It's basically lying to you because it doesn't know what to say, because it's trained incorrectly, or you're asking the wrong question. We needed a lot of prompt engineering, which means you have to refine your instructions to the language model in order for it to follow your instructions exactly. So it's almost like language programming. There was the need for a lot of data filtering and human oversight. We needed to go through the questions and make sure they were actually correct and that they conform to our standards. The reason we had less language model questions than staff questions is because a lot of these questions were excluded, completely excluded, because they were deemed unsalvageable. There was something inherently wrong with the question, so that it couldn't be used. Something like the topic of the question was completely off, or the assumptions that the language model made was completely wrong. But the edits, the large amounts of edits that we needed to do with the rest of the questions is because either of incoherence, the sentences together didn't make sense, there was irrelevant information in the question stem, or otherwise it gave the actual answer in the question stem, and factual errors. So those questions is from the language models what required a lot of editing. And I just wanted to talk about, just very important to note in general, whether you're looking to create questions or whatever the case may be, when you use language models, they must respond. This is part of their primary directive. If you give them something, they must respond. If you ask them not to respond, for example, they will still respond and say, okay, or something. Now, how they respond is firstly what they were trained on, and secondly to what they were prompted to do by the person interacting with the language model. If either of these are insufficient, then you will not get the response that you're looking for. And this is the primary reason why these modern language models hallucinate. If the training data is insufficient or your prompt to it is insufficient, it's going to start making assumptions, because remember, they work with statistical probabilities. If that probability runs out, or it can't accurately predict what needs to come next, it's going to randomly assign probabilities to different things. And we don't know how this works. Even OpenAI does not really know how it works. And because either its data is insufficient or its prompt is insufficient, it starts using the best guess model. So then it just strings a sequence of possible words together. Also important to note is that they cannot do any mathematical calculations. They may sound very intelligent. They may appear to have the knowledge of a mathematics professor, but they are not designed to be logical or reasonable, even though it may appear so. It just follows examples. And as we know, examples can be bad. So for example, I just quickly go through this. I once asked it a while ago, how much volume does total blood oxygen make up? And it pretended to do some calculations, and it came up to 100,500 milliliters, which is 100 liters. That's about the blood of 150 people. And I said, but isn't that actually 100.5 liters? And it says no. If you convert it, it's actually, I think, 10.5 liters, it said, which is, again, incorrect. And then I said, but if you divide that amount by 1,000, isn't that 100.5? It said, yes, that is correct. I said, so then eventually I said, so you're essentially saying that a person has 105.5 liters of blood, and it started arguing with me. I'm misinterpreting it. And I said, no, but this is what you said. And it said, no, it's not. And I said, but isn't this what you just said? And 100,500 divided by 1,000 is 100.5, correct? It said, yes, that is correct. But I am misunderstanding how conversion works. So now it took something completely out of left field and said that I'm not understanding. I don't understand how mathematics works. So I think in this case, it was trained on something like Reddit data or something where people keep arguing with each other. I told it it's hallucinating, and it ended the conversation. So there's an example of one of the problems you can run into when talking with AI. In conclusion, well, the conclusion is probably you can use large language models to help you generate questions. They can be useful, but we as educators need to explore how useful this can be for us. If it takes more drama than we want to use the language model for certain things, then don't do it. If it can help you with something, then do it. Sometimes, as I talked about yesterday when I talked about grading answers with language models, it can greatly reduce the time and energy for that. And if you are looking for simpler questions or very specific kinds of questions, it can also reduce the time needed to create or edit questions. Because as was said in the previous presentation, it takes actually a lot of work to create a very good multiple choice question. Another thing is that academic integrity is essential when using generative AI. If we create questions using language models and we just paste them into our assessments without looking at them, that is not academic integrity. We need to first look at these questions and whether they align and everything like that. And this doesn't only apply to assessments, it applies to anything that we do in education. It is important for us also to develop literacy. We have to spot when the AI is hallucinating. We have to see when it's not doing what we want. We have to know how to instruct it to do what we want. Lastly, I asked it to create a funny quote about language models, and it says, language models are like teenagers. They can talk for hours, but still have no idea what they're talking about. And I think that's quite accurate. Thank you, everyone.
Thank you, Kobus. That was very, very interesting. Do you have any comments or questions for Kobus? Shada, yes, please go ahead.
Hi, Kobus. Sorry that I'm asking questions again about this. It's very interesting to me. So thanks for that presentation. So I just wanted to ask you, so I saw when you gave it information regarding ADH and it generated a question based on that information. First, it checked whether that information was correct. Did you try and give it incorrect information and saw if it corrected it before it made the MCQ? And also, did you, I don't know if, sorry if you discussed this, somebody disturbed me during a presentation. Did you try, does it generate tables for cases? So a vignette with a table of results. Can it do that?
Hi, Shada. Good to hear from you again. Firstly, yes, I have tried to give it incorrect questions, and most of the time, I would say 95% of the time, it does detect that either an option is incorrect or something is incorrect in the question. I think because if you're instructed to follow medical texts, it will follow what is in a medical text and see that the options I gave it are not probable. So it will identify those as incorrect. Sometimes it doesn't. It struggles a little bit, especially when the options are extremely similar. It struggles to do that. Your second question was, can it generate tables with
of results?
Of results, yes, it can. So okay. I've tried that. It's like the one we had yesterday. Ask it to put the answers in a table. It can do the same with a table of results. You just have to specify that it has to be in a table.
All right, that's fine. Thank you. Thanks. Thank you so much.
Thank you again. Okay, there's just a comment from Sharon. Do you have any other questions or comments? We still have about 3 minutes. My other colleague always says that with ChatGPT, don't forget to say thank you when you're done. So it was just quite interesting to see how you were having that the conversation you had also. But yeah, thank you very much for the presentation.
Thanks. Yeah, sometimes a please and thank you still slips in there. But I think if they take over the world, at least we said please and thank you. So maybe they'll think of us.
Right. Okay. Any last comments for Kobus?
I saw a hand, Antoinette.
No, Kobus, this was a mistake. I was just laughing at the comment of please and thank you.
Right.
Right. Thank you, everyone. Enjoy the rest of your afternoon.
Thank you so much. All right.